Hello everyone. There are two different types of changes. One is a physical change and the other one is a chemical change. Folding a piece of paper is an example for physical change. But if we are burning this paper, then we call it as a chemical change. In a physical change, we can always bring it back into its original state after the change has happened. But in a chemical change, a new substance is formed there, and that new substance will have new properties. So here I have a magnesium ribbon. On heating this magnesium ribbon, we obtain white powder. So usually we call such white colored powders as ash. So on heating magnesium ribbon, it combines with the oxygen present in the air and gives us magnesium oxide, which is the white powder or the ash we get here. This is an example for chemical change or a chemical reaction. The substances which take part in a chemical reaction are called reactants, and the new substances are produced. They are called products. In this case, we discussed about magnesium and oxygen combining together when we heated it. So magnesium and oxygen are the reactants here, and the product formed is magnesium oxide. So in short, in a chemical reaction, reactants are transferred into products. During chemical reactions, a rearrangement of atoms take place between the reactants and they form new substances having entirely different properties of the reactants. So a large number of chemical reactions keep on occurring in our daily life. So souring of milk, fermentation of curd from milk, cooking of food, digestion of food in our body, respiration, fermentation of grapes, rusting of iron, burning of fuels, ripening of fruits, all these are examples for chemical changes which involves chemical reactions. So how do we know that a chemical change or a chemical reaction has taken place? So it can be said by some observable changes that happens in a chemical reaction. Such changes are the characteristics of chemical reactions. So the important characteristics of chemical reactions are: the first one, evolution of gas. The second one is the formation of a precipitate. The third one is there will be a change in color. Fourth one says that change in temperature. And finally, the fifth characteristics is change in state. Any one of these general characteristics can tell us whether a chemical reaction has taken place or not. We will now see examples of all the characteristics of chemical reactions one by one. So the first one we are going to discuss is about evolution of a gas. So some chemical reactions are characterized by evolution of a gas. The chemical reaction between zinc and dilute sulfuric acid. It is characterized by the evolution of hydrogen gas. So if we take some zinc granules in a conical flask and if we add some dilute sulfuric acid into it, we will see bubbles of hydrogen gas coming from the solution. So we can say that by seeing these bubbles coming out of the solution, a reaction is taking place. So in addition to this evolution of gas, if we touch on the sides of this beaker, then we can feel some temperature or we can feel the heat coming out of this solution. So a change in temperature is also occurring in this reaction. So similarly, when sodium carbonate and dilute hydrochloric acid or HCl it is taken, or when they react together, they produce carbon dioxide gas. So in short, evolution of a gas is a characteristic feature of chemical reaction. The second property or the characteristic of a chemical reaction is the formation of a precipitate. So some chemical reactions are characterized by the formation of a precipitate. So a precipitate is a solid product which separates out from the solution during a chemical reaction. So when potassium iodide solution is added to a solution of lead nitrate, then we obtain a yellow precipitate which is lead iodide. So there involves a change in color too. Previously, we can see that we had clear solutions, and after the reaction has taken place, the color changes to yellow. So change in color and change in temperature are also the characteristic features of chemical reactions. So both these were observed in the previously discussed reaction. So in the reaction between zinc granules and dilute sulfuric acid, temperature increased. And in the reaction between potassium iodide and lead nitrate, the colorless solution they changed into yellow colored lead iodide precipitate. So change in color and change in temperature occurs in chemical reactions. And finally, the fifth characteristic is the change in state. Some of the chemical reactions are characterized by change in state. For example, when wax is burned, then water and carbon dioxide are formed. Wax is a solid, water is a liquid, and carbon dioxide is a gas. So during the combustion reaction of gas, the physical state changes from solid to liquid and gas. So in short, if a chemical reaction occurs, any of these characteristics features can happen. So the first one was evolution of a gas. Second one, formation of a precipitate. Third one, change in color. Fourth one is the change in temperature. And the fifth one is change in state. It's not necessary that all these 5 features should occur in a chemical reaction. It's fine, any of these changes can happen. But as we saw before, there are some chemical reactions which can show more than one characteristic. Now, these chemical reactions can be represented with the help of symbols and formulae of the substances involved in it. And such formulae or such representation is known as chemical equation. Let's take an example and understand it better. So, zinc metal reacting with dilute sulfuric acid, it produced zinc sulfate and hydrogen gas. So if we write this down, we can write it as zinc plus sulfuric acid gives zinc sulfate plus hydrogen. But this is a word equation. We can change this into a chemical equation by writing the symbols and formulae of the various substances in the place of their names. The symbol of zinc is Zn. Formula of sulfuric acid is H2SO4. The formula for zinc sulfate is ZnSO4, and for hydrogen gas the formula is H2. So, by putting these symbols and formulae for the substances, we will have an equation like Zn plus H2SO4 gives ZnSO4 plus H2. So the substances which combine or react They are known as reactants. The reactants are always written on the left hand side in an equation with a plus sign between them. So the new substance produced in a reaction are called products, and the products are always written on the right hand side of the reaction or right hand side of the arrow mark with a plus sign between them. So the arrow sign pointing towards the right hand side or towards the product between the reactants and the product, this arrow sign indicates that the substances on the left hand side, they are combining together and they gives the substances written on the right hand side of the equation. So a chemical equation is a shorthand method of representing a chemical reaction. But when we write a chemical equation, we have to make sure that the equation is balanced. A balanced chemical equation has an equal number of atoms of different elements in the reactants and the products. But if an unbalanced equation is present, then it has unequal number of masses of reactants and products. So let's see how to balance a chemical equation. For that, let's just take an example of reaction of hydrogen and oxygen to give water. So we have the equation as H2 plus O2 gives H2O. So the first step in order to balance a chemical equation is to count the number of atoms present in both reactant and the product side. You might be wondering how we have to count these atoms. So when we take H2, it means there are 2 H atoms present in it. But if it is 2H2, we have to multiply the number written on the left side of the molecule with the number written at the bottom or as the subscript on the element's symbol. So now for H2O, there are 2 hydrogen atoms and 1 oxygen atom. So when we write a chemical formula for a compound, if there is only 1 atom present in it, we usually do not put the number 1 as subscript to that symbol. For example, in the case of H2O, we write it as H2O only, not H2O1, which means oxygen is 1. We just leave it as such. So in H2O, there are 2 hydrogen atoms and 1 oxygen atom. But in the case of 2H2O, there you have to multiply the number written on the left hand with the numbers on the subscript. So in 2H2O, we have 2 into 2, 4 hydrogen atoms and 2 into 1, 2 oxygen atoms present in it. So now let's see how we can balance a chemical equation after counting these number of atoms. So we were talking about hydrogen and oxygen combining together to give H2O. So we have the equation as H2 plus O2 giving H2O. Now let's make a column that gives us the number of atoms present on both reactant and product side. So the table contains 3 columns, and the first column is about the name of the element or the atom present in it. Then the second column gives us about the reactant side, and the third column tells us about the product side. So if we look into the equation, we know that we have only 2 types of atoms. They are hydrogen and oxygen. So in the first column, we are going to write hydrogen and oxygen. So hydrogen, there are 2 hydrogen in the reactant side. So let's write the number 2 in the second column. And if we look into the product side, there are 2 hydrogen. Now let's see the number of oxygen. The oxygen atom in the reactant side is 2, but at the product side, oxygen atom is only 1. So, the number of hydrogen atoms are equal on both reactant and the product side, but number of oxygen atoms, they are unequal. So, we should need 2 oxygen atoms on the right hand side. So, for that, it's just that you have to multiply 2 at the right hand side of the equation, that is at the product side. So now the equation will be changed as H2 plus O2 giving 2H2O. But let's count these numbers again. Let's redraw the column and let's see how the number changed. So now we have 2 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. And if we look into the oxygen, there are 2 atoms on the reactant side and 2 atoms on the product side. So now there occurred a problem with the hydrogen atom. So that is also easy. So you have to multiply, or we have to increase the number where it was reduced. So in the reactant side, there is a shortage for 2 hydrogen atoms. So we are going to multiply 2 with the H2 gas. So the rearranged equation will be 2H2 plus O2 gives 2H2O. So here, now if we count the atoms, we have 4 hydrogen atom on the reactant side and 4 hydrogen atom on the product side. And if we take the case of oxygen, we have 2 oxygen atoms on the reactant side and 2 oxygen atoms on the product side. So now this is a balanced chemical equation. So whenever you write a chemical equation, you have to make sure that the equation is balanced, because chemical reactions occurs on the basis of law of conservation of mass, which means mass can neither be created nor be destroyed in a chemical reaction. So we have to make sure that the number of atoms on the reactant side and the number of atoms on the product side, they are balanced. Let's take another chemical equation and try to balance it. So here I have taken an example of the chemical reaction as methane burns in oxygen to form carbon dioxide and water. So the reaction can be written as methane plus oxygen gives carbon dioxide plus water. So the formula for methane, it is CH4, oxygen O2, carbon dioxide is CO2 and water is H2O. So now let's write the chemical equation as CH4 plus O2 gives CO2 plus H2O. Now the first step, as we have said before, is the counting of number of atoms on both reactant and product sides. So let's make that column. So here we have number of atoms in reactant side and in product side. So the number of atoms, or the types of atoms present are carbon, hydrogen and oxygen. So in the reactant side, the numbers will be like 1, 4 and 2, and in the product side, the numbers will be like 1, 2 and 3, which means carbon is 1 on both reactant and product side, hydrogen is 4 in the reactant side but 2 in the product side, and if we take the case of oxygen, it is 2 in the reactant and 3 in the product side. So now we can see that the carbon atoms are equal on both sides. So let's go for the other unbalanced atoms, and both of them are hydrogen and oxygen. So let's take hydrogen first. So here we have 4 hydrogen atoms in the reactant side. So there are only 2 hydrogen atoms on the product. So this can be made equal by putting a 2 in the product H2O. So after doing so, we have the equation as CH4 plus O2 gives CO2 plus 2H2O. Now, if we count the number of atoms, let's make that column again. Types of atoms in reactants and in products. So the numbers changed as this. So here we have the hydrogen number got changed as 4 and 4. Now the carbon and hydrogen are balanced here, but oxygen, it is unbalanced. There are only 2 atoms in the reactant side and there are 4 atoms on the product side. So that is also can be balanced by putting a 2 in the reactant side. So let's see what happens to the equation then. So CH4 plus 2O2 gives CO2 plus 2H2O. So let's count the number of atoms again. So here we'll have the number of carbon atoms on both reactant and the product side as 1. And the hydrogen atoms will become 4 and the oxygen atoms will also become 4. So now the chemical equation is balanced. Always make sure that the equation is balanced after you write it. I encourage you to take a few more examples of such chemical equations and try to balance or practice how to balance these chemical equations. So in this sessions we learned about chemical reactions and writing a chemical equation. Hope you had a fruitful time with us. Enjoy your day and we'll see you all in the next session. Until then, take care and thank you.